Hi, I'm Ahmed Daud, and in this session we are going to see ROC curve. ROC curve is actually the receiver operating characteristic curve is another common tool used with binary classifiers. It is very similar to precision recall. If you can see here, similar to precision recall curve, but instead of plotting, if I will zoom in, instead of plotting precision recall versus recall ROC curve, this ROC curve plots true positive rate versus false positive rate. Okay, in the last session we have seen precision recall curve at which on the x-axis we are having recall, on the y-axis we were having precision. Okay, like this. If I will show you here, like this. On the x-axis we were having recall, on the y-axis we were having precision. Okay, but in the ROC case, instead of we have on the x-axis false positive rate, false positive rate, and on the y-axis we were having true positive rate. Okay, so we will discuss what is true positive rate and what is false positive rate. Okay, true positive rate is same as the recall, and sometimes we also call it as a sensitivity. Okay, so it has the formula true positive divided by true positive plus false negative. Okay, you are already familiar with that. So what is false positive rate? I will show you from the confusion matrix. Okay, so this is the on this side we usually have actuals. If I will, okay, on on this side, on the column wise we were having, let's say, predictions. Okay, so what is true positive rate? True positive rate, or you can say recall. Okay, these are the same, and it's also called as a sensitivity. Okay, these three terms are the same. Okay, it means how many positive instances are correctly classified. Okay, these are the total positive instances we have in our data. Out of the total positive instances, how many instances are correctly classified? It means true positive divided by true positive plus false negatives. True positive plus false negative, all the positive instances, and out of all the positive instances, how many are correctly classified? Okay. Now, here there is another, you can say, recall, which is commonly not called as a recall, we call it as a true negative rate. It means how many negative instances are correctly classified. Okay, these total true negatives plus false positives are total negative instances. Okay, we have in our sample. These are, so out of all negative instances, how many negative instances are correctly classified? Out of all negative instances, how many negative instances are correctly classified? This will become true negative divided by true negative plus false positive. We usually call it as a true negative rate. Okay, here I will write true negative rate. Okay, so this is also called sometimes true negative rate or specificity. Specificity. Okay, if you can see here. Now, if I will use another. Okay, so what is false positive rate? False positive rate. If I will write here, false positive rate. It means how many, if you consider the same negative instances, how many negative instances are incorrectly classified as a positive out of all the negative instances. If I write here, how many negative instances are incorrectly classified as positive instances out of all negative instances. Okay, you can consider in this way. So, how many negative instances are incorrectly classified as positives out of all negative instances? So, how many negative instances we have? True negative plus false positive. And here, these are the instances that are actually negative but incorrectly classified. So, this will be here. So, you can see here FPR, it is FPR, false positive rate. It is equal to false positive rate. FP divided by true negative plus false positives. So FPR is the ratio of negative instances that are incorrectly classified as a positive. Now you got an idea who this will be considered as a true negative rate or true positive rate. Okay, but here we are considering true positives. This will be a like here this will be a false positive rate. Here we are considering the negatives instances, but we are calculating the sort of errors. Okay, how much, how many number of negative instances are incorrectly classified, and in case of true positive rate, we are considering how many positive instances are correctly classified. Okay, so we plot in ROC on the x-axis we plot FPR, false positive rate, and on the y-axis we usually have true positive rate. Okay, so now we want such a model which has minimum false positive rate and maximum true positive rate. Okay, and if we are trying to select the threshold, we want such a threshold which at which we have high true positive rate and less false positive rate. Okay, but if usually we use ROC curve for to compare the models. Okay, so we want such a model which will have curve more towards the top left corner to this. Okay, so let's say if this is another curve, this green will be another curve. Okay, if I will make in more precise way, this is another, this will be another curve, let's say, and this is the curve for another model which is closer to this. Okay, we want such a curve which is more closer to the top left corner. What is actually mean? Here you can see this. Let's say you will select an any point. Let's say this one, this point. Okay, at this point, this blue curve have about 0.3 positive rate, true positive rate. At the same point, this red curve have about the 0.5 true positive rate. At the same point, the golden curve has 0.82 positive rate, true positive rate. And at the same point, this green one have approximately 1. Okay, so here and the false positive rates for all the curves is same about let's say 0.19. This is false positive rate for all the curves. So against same false positive rate, which curve is giving highest true positive rate? So this green one is giving you the highest high true positive rate. Okay, So in the same way, like you have calculated the area under the curve, if you want to see the to compare the models in terms of scores, you can calculate the scores like this area. This will be area for the below curve. Okay, area under the curve. So this will be less area. This will be less area as compared to the this red one. So red will have this area. Okay, in this way you can also compare the areas. Like here, if you want to see the area under the curve of ROC, this one, this is the actual curve. If I will uh, copy this from here and I will show you here. Here you can see this curve, this curve, this curve having this area under ROC curve 0.62. Okay, if some model, some another model, let's say another classifier, this classifier have area under curve, area under ROC curve, let's say 0.8. So this will be best as compared to this blue one. Okay, in this way you can also compare the models. Okay, so this is very like commonly used to compare the models. Now you can maybe ask the question. So it is similar to the ROC curve is similar to the precision recall curve. As in the precision recall curve, area under curve we can use to compare the models. We can compare the models and if we can also set up the thresholds in both curves by using both curves. So where we can use ROC curve and where we should use the precision recall curve. For a single point, if you want to remember, where you have imbalanced data, you should use precision recall curve. And remaining all the cases, you can use ROC curve to compare the models. Okay. So what is the reason why in the case of imbalanced data, you should use precision recall curve? The reason is that in the here you can see from here, if I will compare this one with this, now here you can see this is precision recall curve and this is ROC curve. This curve is for the same classifier. A classifier, same classifier have this precision recall curve and this ROC curve. Here you can see according to precision recall curve, our area under curve is very low, 0.42. But in the case of ROC, our area is 0.62, which is higher. Okay, so in the case of imbalanced data, in the case of imbalanced data set, our ROC curve usually overestimates the goodness of a model. Okay, here you can say we can easily visualize it has a very uh, large room to improvement. Like you can have a curve like this, but you have very low curve, and your curve have very low height as compared to other curves that you can have. Okay, your this blue curve is closer to your base. Okay, so but ROC curve, according to ROC curve, it seems that your model is not too bad according to this curve. It seems that like your model is your classifier is not too bad. Okay, it is just because that you are using imbalanced data set and you have seen that in this data set you have predictions, let's say uh, about 300, if you will consider the true values. Uh, you have total 300 samples, and out of 300 sample 200 samples are zeros, and like 209 209, I think so. Okay, we can see from here. Yeah, 209 samples you have here. you have 2090 zeros and 91 ones. Okay, in this data. So here you can see this is imbalance of data set you have. So in case of imbalanced data set, you should prefer to use precision recall curve. And in the case of when you have balanced data, and in all other the cases when you have some sort of good data set and balanced data set, you can use ROC curve. Okay, and ROC curve is good in way of visualizing also, because and it's a different way of visualization. Here, recall is also a score, precision is also a score. But in the case of ROC, this is recall. Recall is a score, but this is type of error. Okay, as you are growing along the x-axis, your error is increasing, your false positive rate is increasing. As you are growing along the y-axis, your score is increasing, and you want such a model that should have like this. Okay, like this curve, which can have high true positive rate against very low false positive rate. But in that case, in the case of position recall, we usually understand in this way. We have a high such type of model which have high recall and high precision. Okay. Or if you are selecting threshold, then also you will select a such type of threshold where your precision and recall both are high. Okay. It's just a way of analyzing your model's scores. Okay, so for a single point to remember, ROC curve where you where you have imbalanced data set, you should use precision recall curve. Otherwise, you can use ROC curve. Okay, so if you want to calculate ROC curve, okay, so you can import a function from the sklearn dot matrix. Okay, ROC curve, and it will work in the same way as precision recall curve works. Okay, I will show you here. Yeah, here you can see ROC curve. Here you will pass the true values and the probabilities belonging to class 1. It will generate different thresholds, and against different thresholds, it will have a range of thresholds, and against each threshold, it will have a true positive rate and false positive rate. Okay, so in this way, you will have a large number of true positive rates and false positive rate for a single classifier. Okay, because the classifier will have, or classifier has given you these probabilities that you are comparing with your true values upon different thresholds. Okay, anyhow, so if you want to plot them on the x-axis, let's say false positive rate, on the y-axis you have a true positive rate, and you can use a SNS dot line plot. Okay, if you want to calculate the ROC score, area under curve score, you can import from the sklearn.matrix this function, and you can pass the same values, true values, and the probabilities. It will calculate the three thresholds for true positive rate, false positive rate, and then it will calculate the area under curve score for you. Here you can see. And if you can, you want to see that like we calculated in the form of in the case of precision recall, just by passing the recalls and precision, we can also calculate by using this area under curve from a scalar dot metric, and we will pass true positive rate and false positive rate to that. Here on the x-axis false positive rate, on the y-axis true positive rate, and it will also calculate the area under the curve, 0.62. Like here, it's the same. Okay, it's up to you what function you want to use. Okay, for the point of view, for the coding point of view, it's very simple. All the modules are available, but what are the concepts behind each module? How or when these modules should use, it is really important. So for now, thank you.